Welcome e-learners and hyperbola aficionados. Here we are on page 2 of section 9.3. Reminder, if you have not taken the notes on this, if you have not looked at the note sheet, there's explanations that are there that are not going to be included here, so you may want to look at that first. But here we go. In this section, we are supposed to come up with the standard form of the equation of the hyperbola with the given information. If we have a passes through point, then we are going to expect to plug square root of 5 in for x at some point and -1 in for y at some point. So let's get started by drawing a picture of this. I have vertices at 0, 4. That's right 0 up 4. I'm not going to rush through that part because people make mistakes just plotting these points in the wrong quadrants. So 0, 4, 0, 0. Those are my vertices. What all did they just tell me? Things I need to know. I need to know the center. I need to know what A equals. I need to know what B equals, and I need to know what, well, I don't necessarily need to know what C is, but I need to know center, I need to know A, I need to know B, and I need to know direction. By direction, I mean this one's opening up and down. So I've got direction. It's up and down. My center is halfway between these, which is just the midpoint. You could use midpoint formula if it's more complicated, but clearly this one is just at 0, 2. A is the distance from the vertex to the center. B, we don't have it. C is center to focus, but we don't have the foci either. So what can we do so far? It opens up and down. That means it is a positive y squared hyperbola. So this is y minus 2 squared, my void, my most interesting value of y, on a squared 4 minus x minus 0 squared on b squared, we don't know it, equals 1. All I need is b squared, so giving me the vertices is a lot. I've got direction, I've got h, I've got k, I've got a, I only need b. And to find b, I'm going to go ahead and plug these values in. So let's see here, see if I can, oh, I got some room over here, that's good news. So I get -1 minus 2 squared on 4 minus yuck square root of 5, but yay squared on b squared equals 1. So I've got, I'll just write this up here, take advantage of this room. This is -3 squared, 9 on 4, minus square root of 5 squared, 5 on b squared equals 1. I'm going to multiply by my least common denominator, as I always do in this situation. The 4's cancel. I get 9b squared minus the b squareds cancel. 4 times 5, 20. Nothing cancels. I'm just distributing that through. Nothing cancels. 4b squared. Subtract 4b squared. I get 5b squared equals add 20. 20. B squared is 4, and that's all I need to know. Final answer. I'll clean it up and put it out here. Y minus 2 squared on 4 minus plain old x squared on b squared. B squared is 4. Don't square it again. Equals 1. And there it is. All right. So this is kind of the whole ball of yarn here. What we're trying to find, pretty much trying to find everything from these equations. The only thing that could make this more difficult would be if they didn't give us these in standard form, as we're going to see when we get to page 3. So here's what I know. I've got, this is x squared on 1, y squared on 1. This is in standard form. They just didn't have the 1's there. So this opens right and left. A is 1 squared, therefore A is 1. B is 1. So we've got I should make a bigger graph. This is going to all be about the graph, but A is 1, B, this is going to do for now, I think. It opens, and I'm just going to go lightly, and if I did it in pencil, I'd probably come back and erase, because we're going to talk about controlling the width of this hyperbola, and that becomes a biggie for us. A is 1, B is 1, and C, therefore, we know that C squared equals A squared plus B squared. C is square root of 2. 1 plus 1, square root of 2. So C square root of 2 about 1.4. So we're at 1.4 from the center in both directions, right and left. Okay. Now what we do to control the width of a hyperbola, we're going to build a little box in here where we know this distance is A. This distance is going to be B, just as if we were building an ellipse here. We'd go, if this was a plus, we'd go up 1, down 1. Of course, it would be a circle. So I go up to here, down to here, and then I build this box right here. And the asymptotes of the hyperbola go right through the center and the corners of those of that box. So our hyperbola vertex is here, gets sucked into that asymptote. Don't let it pull away from the asymptote. I talk about this a lot. If you just have this carelessly wandering away and making it look more like a parabola than an asymptote, you don't really understand what asymptotes do. They pull that curve into it. So it's better just to track right up the asymptote here, just get right on it, but don't pull away from it. And that's what our hyperbola looks like. So center 0, 0, that was nice. Just going through these, check them off. Center vertices are at 1, 0 and negative 1, 0, so I can abbreviate that. Foci are over here. Where did we get that from? Square root of 2. Square root of 2 to the right, square root of 2 to the left. We don't always get to abbreviate that. Up 0. And the equations of the asymptotes, if you got the notes from the book notes are going to put this in y equals form. I don't like it. I like it in point slope formula. And of course we're passing through 0, 0. But here's what we do. We go, it's y minus the y coordinate that we know it goes through, 0. Of course, I wouldn't have to put that normally, but just for moving forward, I think that's good. Y minus the y coordinate equals the slope. Well, what is our slope from here to here? The book's going to say, well, when we have a horizontal transverse axis, then the slope is b on a. But when we have a vertical, then it's a on b. We don't have to memorize that. How do we build this? We went up b over a. There's our rise. Rise over run is 1 over 1 or negative 1 over 1. So plus or minus 1 is our slope times x minus 0. And I would just leave it like that in most cases, but of course the zeros are extraneous here. Y equals plus or minus x. Okay, so I'm going to typically leave these in point slope formula because if you know one thing about me right now, it's like you know that I want the equation to tell me the story about the curve. Okay, once again we're at 0, 0. Things we need to know. I'm going to end up putting the graph down below a little bit here. Maybe organize this better. Center. Most interesting value of x, 0. Most interesting value of y, 0. That makes A 1. It's underneath the positive. B is 4. Square root of 16. C is, let's see, c squared, c's the biggest. Remember, c's the furthest away from the center. Foci is 16 plus 1, a squared plus b squared, 1 plus 16, 17. C is square root of 17. And I guess I have enough room to throw that graph in right here. Center 0, 0. This opens, what's our direction? It opens up and down. It's positive y squared. So I need to go up 1, right 4. Let's do it this way. Let's see, I think I'm going to count by 2's here. So this is going to be 4 eventually. This is going to be -4, -4. This will be up 1, 2, 3, 4. Just kind of giving some scaling here. So we're center 0, 0. We go up 1, down, just like we're building an ellipse. Up 1, down 1. Right 4, left 4. I'm going to put in the little box here. I'm going to extend for my asymptotes. Now, don't make a mistake here. What direction does it open? It's a y squared. It opens up. So it's here, and boy, that thing's going to just go pretty horizontal right to that asymptote. Right to that asymptote. And then square root of 17 is just a little bit more than 4. Just a little bit more than 4. So up 4, just a tiny bit more than 4 is where our asymptotes are. 1, 2, 3, 4. Not our asymptotes, excuse me, our foci. Okay, so let's go ahead and name these things. We've got our center. We need our vertices. Well, they are up 1, down 1. So our vertices are 0, plus or minus 1. Our foci are up square root of 17, down square root of 17, 0, plus or minus square root of 17. And our asymptotes, y minus a y coordinate, that's y minus 0, equals, what's our slope? Well, to build this, I don't need to know AB, I just need to know what did I do. I went up 1 over 4. That's our slope, up 1 over 4. You can see it right here, up 1 over 4. I know what the slope is before I even start. And down 1, left 4. Y minus 0 equals plus or minus 1/4 times quantity x minus 0. But these guys, of course, are, yeah, that's it. That's it. So like it in that form, you're going to see one when we start to have to not have the center at 0, 0, where it's not going to end up in slope-intercept form. Okay, as I said on page 3 on these, if you had trouble on the understanding the notes, you've now seen 2 problems, and 25 is virtually identical. Don't just sit here and wait for me to do this for you. You need to practice this. So you can pause this and come back and check 25 if you like. Okay, 25. Let's draw a line here. We've got a y, positive y squared. So I know this opens up or down. I know that the center is my box 0, my voy 0. I know that A is 4. I know that B is 2. And I know that C is A squared plus B squared 20, the square root of 20. Which I'm not even going to bother simplifying for right now. Well, yeah, I guess I might, but I'll do it in a little bit. You'll see why. Okay, so I need room to go up 4, down 4, right 2, left 2, centered at 0, 0. So up 4, left 4, right 2, left 2, centered at 0, 0. If I call this 1, 2, 3, 4, I got it. 1, 2, 3, 4, I've got it. 1, 2, 1, 2. So up 4, down 4, right 2, left 2. Just like an ellipse, except we're going to make a rectangle. build our box. Asymptotes through the center, through the corners. And now let's open it in the correct direction. This is positive y squared. It opens up and down. So here, flat, and get it to that asymptote. Don't pull away from it. Okay, and finally, square root of 20. Square root of 20 is between 4 and 5. So somewhere in here, somewhere in there. So we've got our center. Our vertices are up 4, down 4. Not right or left, but they are up and down. Our foci are not right or left, but let's see. Here's why I'm going to go ahead and simplify this, because I have a final answer. That's 2 square root of 5. We're up square root of 20, down square root of 20, or up and down 2 square root of 5. And our equations of our asymptotes y minus 0 equals up 4 over 2. Up 4 over 2, that's 2 to 1. This is a slope of 2, slope of negative 2, plus or minus 2 quantity x minus 0. There it is. Okay, a little more going on here, because now we're going to have to translate this 3 to the right and 1 down. So we've got a center of myvox 3, myvoy 1. Oh, by the way, this is positive x squared. It opens right and left. One of the 5 things we need to know. We know that A is 3. We know that B is 1. And we know that C is A squared plus B squared 10, the square root of that. The square root of 10. C is the big one. All right, so they've done most of the hard work for us. Again, it's not like this problem where we're going to have to complete the square, these problems. So let's go ahead and graph. I need to go right and left. Once I'm right 3 and up 1, I still need to go 3 to the right. Okay, so I'm just trying to kind of plot out a plan here. I don't need to go up and down very far from there. So maybe something like this will do it. I go right 1, 2, 3, up 1. There's the center. Now I'm just building an ellipse. From there I go right and left 3. I go up and down 1, but it's not an ellipse. It's a hyperbola. Box it. Here are our asymptotes. This opens right and left. Get it right to those asymptotes pretty quickly. And there's our graph. So we've got our center. Check. We need our vertices. Well, that is 6, 1. And 0, 1. We need our foci. Well, those are square root of 10, which is a little bit more than 3. Barely more than 3. So how did I get to here? I didn't go barely more than 3 from here. I went barely more than 3 from here. I went over 3 and then another square root of 10 over. So that's over 3 plus square root of 10, and then we're up 1. To this point, I didn't really just go backwards a tiny bit. I went right 3 and then came back. Oh, so I can go plus or minus. 3 plus or minus square root of 10, 1. And our asymptotes. Here it is. Causes more problems. I think people just kind of let their guard down on this, but this should not be difficult. The equation of this line passes through this point has a slope of up 1 over 3. Our slope is 1/3, and we pass through the point 3, 1. Oh, well, that's y minus 1 equals 1/3 times quantity x minus 3. What's the slope here? Down 1, right 3, negative 1/3. We'll call it slope 2. So that's plus or minus. And I would leave it like that. I'm certain that your solution guide simplifies that. I should say I'm mostly certain. But I'd leave it like that. That tells me the story of the hyperbola a little bit better. And we know that. I mean, an Algebra 1 student can simplify this. We're honors pre-calculus, honors Algebra 2 pre-calculus students. We don't need to do that. Let's tell the story. Okay, and number 29, if memory serves me, looking at it, this one's just a little bit clumsy because we've got a reasonable shift. We're right 2, we're down 6, and then we're making little micro moves here. So this one, I'm gonna use big diagram for this one, but let's get the heavy lifting out of the way here. We've got a center, careful, 2, negative 6. Oh, by the way, the direction, this is up and down. A is square root of 1. B is square root of 1/16, 1/4. Let's see, C squared equals A squared plus B squared, or, boy, that's really little, or 17/16. So C is square root of 17 on 4. Okay, so big graph here. I need to go down quite a ways. I need to go right a little ways here. And then once I do that, we're not moving very far at all. So let's see. 2, negative 1, 2, 3, 4, 5, 6. And we're going to have a little tiny movements from here. Now the y's fine. We're up and down 1. But right and left just a 1/4. And there is the box. How does this open? Up and down. Where are the foci? Well, square root of 17 is just a little bit more than 4 divided by 1, just a little bit more than 1. They're barely beyond the vertices, but they are beyond the vertices. So we've got center. Let's find our vertices here. Our vertices, we went 1, 2, down 6. So our vertices are right 2, down 6, but up 1, 5. And right 2, down 6, down 7. I will have people that will leave this answer as 2, 6 plus or minus 1. I'm going to expect that you would simplify that. I'm not going to be crazy about that. If that was 6 plus or minus square root of 2, different story, as you're about to see. The foci, they're to the right 2. They start at down 6, but then we go up and down square root of 17 on 4. Plus or minus square root of 17 on 4. And our equation of our asymptotes, well, let's see, it's y minus negative 6 or y plus 6 equals something times x minus 2. Notice it's the exact same thing as down here, back here. Y minus 1, y minus 1, x minus 3, x minus 3. I just need the slope. And what was the slope? We went up 1 and we went over 1/4, but that's 1 times 4, that is 4. So the slope is 4 and negative 4. and that tells the story. So there's a lot going on there. As you can guess, there's a little bit more going on the next page. Hope that helps. Let me know if I can explain it any further.